I'm back after who knows how long. It's been, I think, almost a week now. Adjust this lighting real quick. Other way. There we go. Not as terrible anymore. Alright, let's see what Binary Search has in store today. Hopefully something good. So given two lists of integers, nums and target, consider an operation where you take some sublist in nums and reverse it. Return whether it's possible to turn nums into target, given you can make any number of rotations. So, first thing right away that comes to mind, right? Because you can do any number of rotations, you can technically any number of rotations. Technically, I think as long as they have the same elements, you should be okay. Because what this allows us to do is to say, if we can rotate anything any number of times, we can put anything where we want it. So a couple ways to check to see if this is going to be valid, right? We're going to either A, sort both and compare, or if we want to do it in O of n instead of n log n time, we can make a map, put A into map, remove the elements, then if map size is 0, we're good, and then true. So the question now is, can we have duplicate elements? Because having duplicate elements changes a good bit of things here. Okay, I'm going to go off the assumption, hey, the Chingut, welcome. So, I think this should be good. Okay, we're gonna try and do this in the n time n space way. So n time n space. We're gonna make a set under the assumption that, yeah, it's good to see you, man. Under the assumption that there's no duplicates. So we're gonna do hash set integer set equals new hash set. Cool. So we're gonna do that, and then we're gonna iterate through A and add every element in A to the set. Int I in nums, set.add target. Then gonna do the opposite. Then for int I in target, if set, what's it called? Not set contains I, we can already return false. Because if it doesn't contain it, we cannot make it. Otherwise, set.remove I. And then we're just going to do here, I think we're going to have to deal with duplicates. This isn't going to work. Return set.size is equal to 0. Does not compile. Set.add I. Cool, but this isn't going to work because, yep, we're going to have duplicates. So let's go ahead and replace the hash set with the hash map of integer, of character integer. Oh no, it's just integer. It's going to be a map. And we're going to just replace this as well with map for consistency's sake. We're going to do map.put I map.get or default I0 plus 1. So we're going to add every single one of them into here. If the map does not contain the key of I, pretty much if there's no key for I in the map, we can return false. Otherwise, we need to do this. We're going to do that, we're going to decrement it by 1. And then we need to do a check. We'll say if map.get I less than or equal to 0. Pretty much if there's no copy of that element in there, we're going to remove it from our map. And then we just need to return whether the size of our map is equal to 0. Should still work the same way for this. And this should remove any issue we had with duplicates, just like that. Though it is still fairly slow, and I'm curious about what way would potentially be faster. Because, I mean, sorting it into n log n, in an n log n time complexity, and then doing an O of n iteration is still slower from my understanding. But let's see maybe if I run it a few times. Goodness, it's so slow. Phone reduces to checking whether both strings are an anagram. In a sense, yeah, that's kind of what we're trying to do here, by checking pretty much if they contain all the same characters. So I've done this by utilizing I've basically solved for an anagram, now that I think about it. So okay, let's see what we got next here. Append list to some target. You are given a list of integers nums and integers k and target. Consider an operation where we choose an integer which is greater than k, greater than negative k, and less than k. Consider an operation where we choose and append it to nums. Return the minimum number of operations required such that the sum of nums equals the target. Huh? Okay. A little bit confused on this problem as a whole, but... So we got 3 here, and 2, we can append -2 to get us to 1. Okay, so first things first, for this problem, we want to sum up nums, see what we have. Then, check if, let's say, assuming that target is greater than nums. So, what we need to do is add k until difference is less than k. Then we return that plus 1. And for a negative, we just do the same thing, except in reverse. And that should be a fairly easy way to do it. Okay, let's give that a shot. So first things first, int numSum equals 0. For I in nums, we're just going to do numSum plus equals I. And then we're going to have a split branch here. I'm sure we can do it without kind of a separate split branch. It's going to be reusing a lot of code here, but nums less than target. Okay, while nums sum, while target minus num sum is less than k, and let's keep a counter here. Int added minimum number of operations required. See, a minimum number of times to append some variation of k. So we're gonna, until we have a distance of less than k, we're going to do numSum plus equals k. We're gonna add k to it, and then increment our counter by 1. The counter we never instantiated. There we go. We're gonna do added plus plus. Once we get to the point where adding 1k, we'll set it to right on target, or adding anything less than k, we'll set it to right on target. We can just go ahead and return added plus 1. And then, in the else case, we can pretty much, I think, copy the same logic. While nums minus target this time is greater than k, We're going to subtract it from nums, and we're going to do the same thing with that logic, and here we're going to do return 0 for the time being. Although this might be unreachable code. Go. Bad. Oh, num sum. There we go. Gotta make sure we utilize the right variables, not the arrays. Okay, yep, that's an unreachable statement, just like I figured, because we have a exit case in both of our if blocks. Okay, wow, that's wrong. Let's see. We were supposed to get 3, but we got 1. How do we actually, what are we doing wrong is the question. Okay, while target minus num sum is less than k, so num sum is equal to 3, right? I think this needs to be greater than k. I think maybe an abs. Okay, let's try it with this positive one. There we go. But it's going to fail on the negative ones, right? Oh, okay. So it's greater than k, right? So what we're gonna do then is say if num sum equals target, I'm going to return just this. Otherwise, we need one more operation. Got him. Okay, this one's just not going to work. So let's handle this case here. That shouldn't have worked, but I guess it works. Alright, let's get on to like the supposedly more difficult questions. Packing boxes. Given a list of integers nums, pack consecutive elements of same value into sublists. Note, there is only one occurrence in the list. It should still be its own sublist. So this is going to be... See, this is the one thing I don't like about binary search. These sublists, the fact that it expects an array return means that I'm going to need to... if I want to do it with lists, I'm going to need to have a lot of overhead to convert the lists into arrays. However, this is very much doable without a list. Using those lists is going to add a lot of time complexity that is not needed because we know they're all going to store the same value. So lists are going to be super heavy, so we're just not going to touch them. What we're going to do for packing boxes is we're pretty much going to calculate and keep counting until we find a new value. So we're going to set cur to first element. Then what we're going to do from cur is go until we find a new element. Then we're going to make array of size of old element count fill it, and add to list. We're still going to need to use one list, but it's not going to need to be a list of lists. And that saves us a lot of overhead, because instead we're converting pretty much one list to an array and swapping what those values are, rather than having a list of lists and then having to convert each of those lists to an array and then having to convert the main list also. The issue with the fact that it expects arrays here is just the fact that like we never know how many distinct values we're gonna have here. So let's just try this. So list. Oh, we can't have a list of integer arrays, can we? Let me look that up real quick. See if we actually can. Array list of integer arrays. So wait, we can have a... See, because the thing is, it expects a primitive integer array rather than like the wrapper class. So I guess we do just have to do it this way then. Okay. Lists equals new array list. The hint for 3. I haven't even looked. What is it? Implementation. That explains so much. So, first of all, will this even compile? I think it needs to be this. Man, this overhead is gonna be so nasty. Cool, that compiles. So you don't actually need to declare the rest of that. So let's first of all keep track of the current int that we have. I guess since we're already using these lists, I'm not gonna do it with the method where you just keep track of the amount of them. I'm just going to... I'm just going to do it by adding them to the list. So, for int I equals 0, I is less than nums.length, I plus plus. Cool. So what are we going to do here? Say, if nums at I does not equal cur. This is going to be our more kind of full one. So what we're going to do is every time we're going to, first of all, make a list. List results equals new integer. Wait, hold on. List integer temp equals new. Oh, Snailman, good to see you. Welcome. List integer temp is new array list. Otherwise, we just literally do temp.add nums.i. Still an O of 1 access, so it doesn't matter if we add cur or this. Alright, so otherwise, what we're going to do is say list.add temp. So add or put together a list. We're also going to create a new list to start shoving things into. Hey man, good to see you. Welcome. So we're going to do that, and then we're going to set cur equals to nums at I. I think, okay, let's do println list. It should implicitly call toString. Right, we need to not redefine it, we just need to reassign it to a new list. I printed 44 nothing 66. And just no ones. I think it's one of those fence post things again. We need to do temp.add or list.add temp. To one, add the last one. So we are dropping an element everywhere except the first one somehow. Oh, we need to right away do temp.add nums@I. Because once we do that, we're technically not adding that element. We're just making the new list. 44166 4 ones, great. Now comes the nasty Java overhead part of it, where we need to convert this garbage to a list, to a 2D array. It's the part I don't like about Java, where we can't return these lists. Something like JS, we would have been able to do the same operations utilizing just the built-in array, because it's not statically sized, it's dynamically sized. So how do we actually, it's been a while, so int, let's call it result. This sizing is going to be list.length, list.size. Oh goodness, we're up to 5 viewers. Welcome everybody. If you want to join the room, it's exclamation point room up there. Hey Fal, good to see you. Any news on that Google interview? Any updates? I know you said the final was like, what, a month away? Okay, and then let's set this to size 1 because we're going to reallocate it anyways. So then, for list of integer I in our list, we're going to pick apart that list, going to onsite in 2 weeks, preparing right now. Hey, best of luck, man. It's kind of scary, not gonna lie, because so nerve-wracking until you just kind of get it over with. Okay, so list of lists. Yeah, Microsoft, if you go through the news, yeah, they're going back in person. I think they said February 28th. People have to initiate like plans to relocate to be in office. I think default is about 50% of the time, so I think 3 days a week in person, and 2 days a week. Got lucky a while if you have questions. Hey, Maxwell, you made it through the Google final? That's sweet. But yeah, I mean, it's all very manager dependent regarding if you go in person. So, I mean, I'm starting early April. So I'm hoping that I can talk to the manager, and if the manager's cool with it, I can technically stay full remote. Should be. Okay, what we're gonna do is do... crap, so int hold equals new int. And look at that, man, our little community here helping each other out. Of list.size. Then we're gonna go through the list. Int I equals 0, I is less than list dot temp list, sure, because we already have a defined list. This is just not going to compile. I don't know why, but I get the feeling this is gonna fail terribly. Like, I have the problem solved. Now I have interviews from the other side of the table. Really? Okay. Almost as bad. If you don't mind me asking, kind of, where are you at with your sort of CS career? Because I know quite a few of us here are students trying to get jobs. I assume if you're doing interviews from the other side, you are, I'm assuming, somewhere higher up in Google then? We're gonna call this hold.length. Senior software engineer. Wow, okay. L5. Goodness, hold on. Let me look this up real quick. Because there's so many different leveling, like, conjectures for all of these things. Jeez, okay. Well, congrats, man. Joined in 17. Man, I bet your stock options kind of went nuts during these past few years, huh? I was kind of wish I was able to get in the job market earlier before everything exploded and was able to sell off before everything came tumbling down. That's awesome though. It's great to see that there's, yeah, I don't know the other companies' levelings. Yeah, no, I think Microsoft is like, because Google's got like level 5, 6, whatever. Microsoft, you start out at level 59, which doesn't really make a lot of sense. I mean, they really just kind of tossed random numbers and letters, it feels like. No, that's really cool. So, what's got you, out of curiosity, watching an interview prep stream on Twitch on what should be or another random Tuesday morning? Okay, so hold at I equals temp list dot get at I. So this should allow us to fill in our hold list, and then once we finish this, we can do. Ah, crap! This can't be a for each loop because I need the indexing. I can't use J for an outer loop. I have to fix it. 0 I is less than list dot size. We're gonna do list integer temp list. I have to redeclare it here. Do enjoy the puzzles. Yeah, it's definitely puzzles, all right. That's all I can really say about it. List.get I. These are fairly easy questions. I've reset my sessions, so I end up getting questions with like, acceptable acceptance rates. I've done a fair share of these over these past 6 months. I think I've been at this. So I feel like I've gotten pretty good at them. I think it's better to do this one iteratively. Like compare to your answer array. I mean, it's also nice to see other people. I had to do a ton of phone screens. That is really tough. Yeah, it's not easy on the other side, but once you make it through, I feel like it becomes a lot more enjoyable. Like compare it to your answer array. See, that's kind of what I'm trying to do here. Just because I need to, all I'm doing this entire chunk is just because Java won't let me return like lists. They're expecting a 2D integer array, but I can't solve this question, I don't think, by using an integer array. I need to use a list because I don't know how many distinct elements I'll have, so I can't declare the array ahead of time. Okay, so we're gonna do result at I equals hold. And that's just gonna be it. And I can't wait for this to give me so many compilation errors. So Max Flow, give us a little bit of insight on what it's like being a senior engineer at Google. What's got you, I guess, in this sort of very hot job market, deciding to stick at a company like Google, for example, rather than hopping to any of the other FANG companies? Yeah, see, that's what it is. Like interviewers, they would allow you to return lists, but I can't change the return typing on binary search. More often than not, it's not even like, because what I realized from my interviews with Google especially, they did not really care about like, oh hey, are you returning like exactly the right type, or are you returning exactly this? The extent of Google's interview was pretty much like a glorified notepad. It was just a notepad with some pretty syntax highlighting. Although MaxFlow, see, one thing I would, if you could bring up with your having empty input is kind of dumb. Yeah, I'd assume anyone using the function would know how to use it. What is it expecting back? Just an empty array. Because yeah, one thing I would like to see if folks in the actual problem, let's boilerplate, yeah. One thing I'd like to see is parentheses completion and like curly brace completion. Because the amount of times I've, which is why Python is better than all. Yeah, but Python's slow. That's all I can say. It's very powerful, but it's slow. Because like the amount of times in the Google interview where I was like, okay, something's not lighting up, and it's because I did this, and then forgot to complete it because every IDE auto-completes them for you. So if nums.length equals 0, I don't know, temp equals new. How do I even return a, like that? Because yeah, I mean the Google I was really glad that the Google interviews weren't expecting like a specific sort of output, rather focusing on boilerplate. Because let me tell you, man, some of the code I wrote for some of those solutions, there would be I'd have had to spend like half the time not even debugging, but fixing compilation errors, because it just probably would not have compiled. All right, I'm gonna take a minute break here and come back and solve some of the deepest nodes. This just looks like a DFS, if anything. Sticking with Google because I really like my manager and I like the respectful climate. That being said, I don't have experience outside of Google. I mean, what more experience can you really need outside of Google? I mean, Google seems to be kind of top tier for work-life balance, seems to be top tier in terms of salary, obviously. And it also, I mean, having senior engineer at Google on your resume, I feel like puts you ahead of the game in terms of most interviews. Because I mean, who's going to ignore the resume of someone who's got what, for 17, that's what, 5 years at Google now? Because yeah, I'm hoping to stick around at Microsoft long enough to internally transfer somewhere. Hopefully, honestly, I'd be super excited to work on some like VR or AR technology. I feel like that's kind of where I want to end up. Like if I got to work on whatever teams are working behind the HoloLens, I feel like that'd be the most like interesting thing. So we need to solve. How do we keep track of the depth here, right? How do we keep track of depth? This one's obviously probably going to be a post order. Ended up close to AR accidentally. Wait, Google does. What does Google do with augmented reality? Am I missing something like terribly? Because I don't recall any sort of Google product or service. Actually, no. Who am I kidding? They have their whole like. It's probably like an app thing, isn't it? Yeah, no, I cannot recall like a major product that Google. Walking navigation. Oh, that makes sense. How do we solve this one? So, at any given point, let's say we are at this node, right? We want to go. We somehow need to see how deep we are. It has this augmented reality view that overlays directions on the video feed. So like, if I were to open Google Maps and put on directions while walking, I could enable like a VR overlay of the. Huh. I've legit never heard of that, but it does seem super cool and super helpful, especially because I don't know, it doesn't track walking the greatest. I'm gonna have to try it out, man. I'm gonna have to try it out. Especially knowing that one of the people working on the team behind it was in my Twitch chat. I feel so famous now. How the heck do you do this? Oh, I'm dumb. You don't need to sum things up. You need to pretty much find the deepest level and then sum everything on that deepest level, pretty much. I think, if that's what it's asking. Yeah, this one's kind of weird. I'm actually kind of not sure how to tackle it. My best guess would be to... It's a very, very broken way to do it, I think, but... Yeah, 2 iterations. One to probe the depth. So we need 1 iteration, probe depth, and second iteration to sum up everything that is at max depth. So what I'm going to do first of all is solve it using kind of global variables just to get a working solution. So int max depth, and then int sum equals 0. So we're going to first of all have a public void find approached with BFS in 1 iteration. I'm really curious if you were able to do it in 1 iteration, because I don't know how you can, if you can do it with just this method, because you need some way to keep track of the depth there. Public void find depth. Let's do int depth equals 0. Wait, no, what am I doing? We're gonna do root as well as depth. If root is equal to null, we're going to just return. Otherwise, we can say max depth equals math.max of the current depth and itself. And then we can do traverse root.left and right. Find root.left. I'm really curious if you're able to do it in 1 iteration, Snailman, with a BFS depth plus 1. And we're going to do the same logic for traversing the other direction. Just like that. I don't know why I changed it to a -1 for depth, but we're going to go ahead and just not do that. So this will allow us to, at any point, find the maximum depth of our tree. So what we're going to do is, first of all, do find depth, pass in root with a depth of 0. Then we can pretty much utilize this same logic. It's going to be a bit of poor code reuse here. If root equal null, let's see. Then we're going to do if depth equals max depth. We're going to do sum plus equals root.val. And here we're going to do, call it something like find sum Alright, and then at the end of this, we're going to return the sum. I'm very, very interested to see like a one-pass solution. Depth. See, I intentionally left these like this so I wouldn't have to erase anything, so I could just fill them in. 100% intentional. Okay. Perfect, and should be it. There you go. Now, how can we do this without utilizing global variables, is the question. I guess to do this without utilizing global variables, what we can do is keep track of the int max. Oh, no, because that method relies on having the max depth. I guess what we can do is have this one return an int sum equals 0. What we're gonna do is say, we're gonna have the depth. If it's 0, if it's null, we're gonna return 0. If the depth is equal to the max depth, we're going to keep track of a local sum equals 0. Then here we're gonna say local sum plus equals the root value. And then we're going to, for readability's sake for now, do int left equals the left, int right equals the right. And from here we're going to return local sum plus left plus right. This can definitely be condensed by a lot. Does not compile. Where are we? Oh, semicolon. Perfect. That should still work. It is by a long shot faster. Okay. We can get rid of this by, I think, doing this real quick. Max step. Can it happen that you need to sum local sum left and right? You make a fair point. You'll never need to sum up local sum because if you have anything from left and I'll adjust this condition a bit later, but yeah, if you have anything in left and right, that automatically means local sum is going to be equal to 0. I want to eliminate this global variable by taking max depth here. We're going to pass max depth into here. Dislike this approach? Yeah, it's not. I'd assume there was a more clever one. Traverse the tree twice. I assume this one's yours, right? Yeah. Okay. Yeah, I can see why you like the Python way. It's very, very clean. Okay, so if current is equal to rum sum plus equals current exists, the running sum plus equals the curve value. Interesting. So doesn't change the complexity. Yeah, so I guess, like, I mean, in the end, obviously, it's going to be slower to traverse the tree twice, but I guess I can pass in, like, a max depth here as well. Yeah, complexity is the same. I'd optimize for obvious correctness. Okay, here, I'm gonna, let's say we don't, is it possible for me to read your solution for another problem? Yeah, it's pretty much like that. I mean, if you can do it faster, you obviously want to do it faster. I just can't, in my mind, come up with I can't come up with a solution to that one right now. I still need to look at yours and see how and why that works. Number 2. So yeah, curious. Okay, so you're. Wait, what? Okay, what does this counter method do here? Oh, okay. What does counter do? I don't know what that does. Okay. So this is. I want to see your BFS one again. I want to see why it works because it looks like you're keeping a running sum, but I'm a little bit confused about because we only want to sum the lowest node, right? So you're oh wait, so you're just kind of you're doing it in a sort of level order traversal, if that makes sense. So what you're doing is say you have this I'm not on the right problem here. Let me go to the 4th one. So let's say you have a 0. Then you go from 0, you keep a running sum, and if there's anything, yeah, leveled BFS. If there's anything else in the tree, you keep going, and you keep going because the BFS is taking it at levels. You know that once you run out of other nodes, you've reached the bottom level, and then that's the running sum that you want to return. Very clever solution. I didn't consider a leveled BFS. Because when I was thinking about it just as a BFS, I was a little confused regarding how you would be making the distinctions between levels. This is a very clever way to do it. I'd never considered doing it this way. I think so. Because granted though, I think this way would technically be preferred because space is cheaper than like computational power. So while this one doesn't utilize any extra space, it utilizes more computation. It's funny because on paper, technically this solution is... Yeah, it's funny because on quote-unquote on paper, this solution is I think faster because it's technically on time O1 space, but I think practically yours would be the approach. I think that would be best. So the call stack is OH. Interesting. Yeah, I never really considered that. Very interesting. That's why it's always great to see other people's solutions, because this isn't something I would have come up with on my own. Because seeing trees, I'm very locked into this like recursive way to do it. Yeah, I guess that really, like, the approach that you'd want here would depend on, let's say if you're doing this for a job, I'm not sure in what application you'd be doing this on the job, but let's say you know, for example, that you have like hundreds of thousands of little trees, then I think your solution would be the preferred one. BFS so easy in Java 2. It's I guess so. I mean, you're really just taking like this syntax, and obviously it's going to be a lot more verbose because it's Java, and you're going to have a lot more stuff. But so yeah, because I mean, okay, I've seen a lot of people using like double-ended queues. DQ of tree objects. Oh yeah, for sure. I mean, you can declare it as like, I mean, if you're doing just a BFS with a linked list, it'd just be something like this. I think tree queue equals new linked list. So something like this would allow you to declare a single one. Yeah, array lists are pretty chunky. I mean, I think utilizing a linked list would be the appropriate way to do it, because I mean, there's never really an instance where you need to grab from the back of the queue. That's good to know. So what would you say is like the issue regarding until you realize it contributes to space? Oh, because every recursive call adds another like a call block onto the stack of methods. So the further you go into recursion, the more stacked up things you get. Man, there's so many things that you don't consider in CS, like until you get into the higher level ones where you're looking at like operating systems, or you're looking at goodness, what was it, like the more sort of hardware level stuff and the implications of some things you do. For example, like recursion seems, you know, fine until you again realize like that, where, you know, the more recursive calls you make, the more things get kind of stacked up, and if you go high enough, you just get this big stack of calls that then needs to be uncalled. Okay, I guess for the time being, let's go ahead and go back through all of our problems and go through and see if we can do like a time and space complexity analysis of all of these. So given two lists of integers, basically you have 340 problems on binaries. How many do you have in total considering LeetCode and other platforms? And the stack is a lot smaller than the heap. Yeah, so 340 in binary search. I think honestly most of my stuff has been done in binary search. So maybe LeetCode maybe has like 30, maximum 40 problems solved total. I've never really been... Honestly, I prefer the font and color scheme of binary search so much more that most of my stuff has been done in binary search. Granted, it isn't, I don't think, an accurate representation of what I have solved here, because keep in mind, I've got my... where do I can't remember how to check my session. Sessions. So yeah, for example, I have this session with 198 and 139, then this second session that I'm currently working on, which is 48 and then 46. So there's, I think, a bit more than that, but most of my stuff is binary search. Granted, it's been done over the course of like 6 months, so if you look at my little calendar here, this is when I was looking for internships. This here is when I was looking initially for jobs, and then it didn't count here. I started early January, but it didn't count because I wasn't solving technically new problems, even though I was still practicing. So, this problem boils down to pretty much, is nums an anagram of target? Because by allowing any number of rotations, you can pretty much do a bubble sort on the list, where you swap just these two elements and these two, then these two, then these two, and you just bubble things up to where they need to be, allowing you to, in a sense, sort the list. So all I did here, I think Python has a much better solution to this, but what I did was I made a map, I added everything from our nums list to the map, I then subtracted everything from target, and pretty much said, hey, is there anything left? Python solution for the first problem. Is it one? Really? Curious to see it. So this one, the reason I went with utilizing a hash map instead of utilizing just sorting it, for example, because this, even though it does become O of n space because of the map, utilizing these two traversals keeps it an O of n time complexity, and doing it in O of n time rather than n log n for both lists to sort and then another n traversal makes it a lot faster. So we're sacrificing a little bit of space to gain back a almost like, I guess, degree of complexity from n to n, from n log n down to n. Yeah, what is this? This is what I'm curious about. On your LinkedIn CV. I personally don't. Yeah, I've seen a couple people do it, but those people are the ones that have like every single question solved. And the interview wouldn't allow counter, which makes the solution trivial, I think. I'm not even sure what counter does, to be honest. Counting instances in a list is pretty trivial. So I'm assuming this returns some sort of like count of each number. Alright, second problem. Appending list to some target. What we're doing here is obviously special dictionary in Python. Yeah, I tried a Python course on Udemy, man. I could not get the hang of Python. I think there's like a bit of weird scoping with it as well, where like its scope can be different than what you're used to with other languages, and I think that threw me off for a bit. So for this one, what I did was I pretty much summed up our nums list to see where we stand, and then it's, I guess, a sort of greedy approach. I don't know if it's in there's no tags. So yeah, what we do is we, starting at this number, we just keep adding the most that we can, because that's the most efficient way to do it, until we have k or less of a difference. At that point, we know if by adding one more, if it's less than k, no matter what, we can add some number between 0 and k to it to get up to the number that we want. So that's why down here, I keep adding to numSum, and I keep keeping track of the amount that we've added. Then, if at any point we've pretty much reached our target, we know we don't need to add anything else. If not, we're guaranteed that the difference is less than k, meaning we just need to add one more time. And I do the same thing for negatives, and I'm sure there's a way to do it without like copy and pasting this code, but I'm also not sure why this works. I don't know why I needed to implement it here, but not here, but I guess it works. It's pretty fast as well. So this one runs in, what is it? Probably O of n. I'd assume it's like constant space, but like O of n time. See, the for loops alone here, right here, makes me think O of n, but I really don't know. I'm gonna assume O of n. Maxflow, you can correct me here if I'm wrong, but I'm gonna go with O of n on this one for time. And the ones that throw me off the most are like when you're working with graph problems and they ask you, hey, what's the time and space complexity of like these graph problems? And it's like remembering, I think it's the have constant time solution for 2. Okay, let's see that. Okay, nums.reduce. Wait, hold on. Accumulator value, accumulator first value. I don't think it's constant time. Because this sum, this reduce function, it iterates through the entire list. So I think it's still O of n. I'd assume. I was about to say, man, how do you sum up reduce is linear, isn't it? Yeah, should be n. I was about to say, how did you manage to sum a list of numbers in constant time? I was like, that's a breakthrough right there. Because yeah, when I think it's regarding graphs, it's like what is it? It's the not identity list. Oh goodness, what is it called? The graph, like the graph representations in lists in adjacency. That's what it was. The adjacency list I think is done in O of n, O of e plus v, while like the working with the adjacency matrix is like e times v. Still solved them all though. I need more practice. So yeah, packing boxes. This problem, we can just ignore this whole chunk because this whole chunk is just Java overhead. Like you can't really go about not doing that. So all I did, aside from this dumb edge case where there's nothing in it, so pretty much my first instinct was to keep track of how many times the number shows up, and then once we find the new number, we know how many times the previous one showed up, we make a list, fill it with that number that many times, and then just return it. And that would work if this wasn't Java. But because it's Java, it's just easier to make a list, and then just every time we find a new number, we make a list, and we keep adding to it until we find a number that's different. Once we find a number that's different, we add this to our list of lists, which separates it like this sort of into its own sublist. We make a new list and we keep doing that. Then down here we have this garbage to convert a 2D list into a 2D array. And there has to be a built-in function to just do this for you. Like, there's no way that they didn't think, oh hey, people would never need to convert, a 2D list into a 2D array. It has to be something to let you do this by default. This is done in, I believe, constant space and constant time because, not constant time rather, like n time and n space. I don't know what I was thinking, because we do only iterate through this array once, and the n space, I think it's still maintained because we at the end store the same amount of items in the list. So granted, no, there's no way it's constant time. For space, it's either constant or it's O of n. I'd say, honestly, ignoring this, because this is unavoidable, this bumps up our space. But I'd make the argument it might be constant space, because we are only storing the original values that we got, so... Alright, let's move on to this last problem. Sum of deepest nodes. The BFS solution, Snailman, was really cool. Not gonna lie, I think I would honestly prefer to do that one. It's very, very clean, very well done. But this one also works where I know there's gotta be a way to avoid this max depth counter. You'd have to probably just do a post order instead of a pre-order traversal. But we find the maximum depth, and pretty much in the sum, we go through and we just kind of add everything up, but only if it's on the deepest level. You did make a good point, Max, though, that with this local sum, if we're ever adding left and right, we know this is going to be 0 because left and right are always a level deeper than our local sum. So I think probably... I guess the way to do it here would be to say... let's move this down here, right? Take this, I'm going to move this here. Okay, let's actually move it, not just get rid of it. Let's do that. So what we're gonna do is say if depth equals max depth, return root.val, else return. And I think what we can actually do to make this even quicker, we don't even need to do this traversal here, because there's no point in doing it if we're going to return the, oh goodness, okay. Yeah, there's no point in doing a traversal if we know that we're not going to return its value. Just gonna waste space. And we're going to get rid of that. We're going to get rid of this as well. And I think this should really be doing the same thing. There you go. And it should be even faster. No, not today. But yeah, this is a much cleaner solution. I really like this code compared to what I wrote initially. So I think really that's going to be it for me for today. It's a good work through, nice warm up sort of into preparation again. I think my extent of practice is going to go until I get a team match with Google. The only thing is, they've said their team matches might occur by like end of March, so I might be here for a while. But I've kind of made a commitment here to keep whoever's watching updated regarding that Google progress, because I mean, I think from the very beginning it was hey, I think you can return max depth too. I think, okay, I'll do this real quick. Int max depth 0. Yeah, so we're gonna do gonna do that. Gonna return an int here. Finally out of class. Don't tell me you were just doing. Were you just doing binary search in class? Okay, so we're gonna do this down here, and we're gonna return left equals that, int right equals that as well. Then we're gonna return math.max of depth verse depth, and then max left, and then right. So this should just give us the maximum depth out of all of these two. I think. Okay. Let's do this real quick. Let's do system. And then I think if we just pass this max depth in, and I think we no longer need the global. Does not compile. Where at? Find depth. We also need to pass in max depth. And we need to do this at every step. Oh, yep. Delete it. Yep, you're declaring max depth twice. Okay, let's pass it in here as well as right here and then right there. Ah, stream lag. Yeah, I'm seeing so many warnings about dropped frames, but that's just kind of how my internet connection is. Pretty sure like nobody in this household can use the internet while I'm using it. Okay, we also need to do that. Does not compile still because I forgot to give it a type. There you go. Still doesn't... What do you not like? Oh, term 0. Find depth. There you go. Sweet. And there we go. We are solving it without any global variables. The one big thing, I keep stressing it for pretty much everyone, especially like in the university club that I'm a part of, that like post-order traversals are your friend. Because pre-order lets you solve from bottom up, but post-order, the beauty of the post-order traversal is the fact that at any point, you already know the solved state of the tree below it, so you can make any sort of decisions you need to make based off that. And goodness, I think that the only reason I made it through that Google final and the only reason I'm waiting for the PA match is because of the sheer amount of time that I spent on this website. I checked my streaming hours, I think since September of that past year. I think I've done about, 80, 90 hours. You don't use max depth and fine depth, do I not? Yeah, I think I've got about 80 to 90 hours of just streamed practice. That's not counting the sessions that I did on my own. I think you do really well. Is there explanation, thought process, 10 out of 10? Thank you, I appreciate that. I think that's also one of the biggest perks of kind of starting to stream. I remember my first couple streams, I was just garbage at explaining things. But at this point, yeah, very clear communication. I try. I mean, it's one of the, I think, the most important things for SDEs, and I think it's very underrated. You could be the greatest developer, but if you can't explain your solution, your thought process, and why you got to the solution you got, you're just going to, I don't think you're going to particularly go very far. Wait, why the heck why am I passing in max depth here? I'm never using it. You make a fair point. Because yeah, I mean, after months and months of doing this daily, I also trained for interviews with friends on the whiteboard. It's definitely a very big help when you can explain your solution. I think I got, let's get rid of this max depth, don't need that. Don't need to pass any more things without the question finished. I think my first Google interview, it was, goodness, okay, almost top tier solution. Yeah, no, the interviewer it was very difficult. I mean, the problem itself was a very challenging graph problem from what I've seen. It might have been like elite code hard level, but the interviewer was just not very communicative. Kind of, I could hear the Slack notifications going off in the background, and I could see him like visibly moving out of frame to respond to the messages, and I was like, come on, man, I'm here for like 45 minutes, please. And I got my questions ignored a couple times, but I mean, you gotta smile your way through it. Yeah, millions of... Another question, because I think my thought process was clear enough. Millions of code monkeys, not a lot of code monkeys who can communicate. Yeah, the code monkeys who can communicate probably end up making more. Yeah, it's okay. It happens. I mean, maybe he wasn't having the greatest of days either, but what matters is it's over. I was very stressed, I'm not even gonna lie. One of the problems that was the first time that I dealt with like an infinite stream of input, so I had he was like, yeah, so what's the time complexity on this? I'm like, well, I mean, you're giving me an infinite input, and it was like, it just threw me off. But overall, yeah, I mean, overall, I think what I did pretty much for all my Google interviews, answer whatever questions they may have, introduce myself. They gave me the problem, I asked a couple of questions to clarify, I made a block of comments where I was like, okay, here's what I'm thinking, kind of, I want to, sort of like I do here, but obviously I was a lot more professional about how I wrote it. So I just wrote out these comments on top, and then I pretty much followed implementing that process. And at the end, if I ran out of time, and sometimes I knew my solution wasn't optimal, but I guess the trick was, like, I knew I could implement a suboptimal solution, but it's like, what the optimal one is. I knew I couldn't implement that in time, so I went suboptimal, and in the end, I was like, oh, looking back at this now, if I had more time to do it, here's how I would do it. And in like 5-10 minutes, I'd give like an explanation of the optimal solution. And I think that left a good after sight, I think, just because it's like, okay, I implemented something, the logic was there, it all worked. And, you know, had I had more time, probably not in that interview, because, again, the optimal solutions for hard questions are difficult to implement, but I think it goes to show the initiative of like, hey, you know, if I had more time, I could have done it this way. I know this way's faster, so yeah. And I feel like after, because my very first phone technical interview was, it was with Google for a winter internship. So it was supposed to be for winter quarters, so starting January and ending in March. And that was my very first ever technical interview, and I was sweating bullets. Like, I forgot arrays existed, and I did a thing where, like, I needed to store two values. So what I did was I made a map, and I stored one value as the key and one value as the value. Then, to get those, I set up an iterator, because I never knew what the key was. I iterated through the map that had one element. I then found the key. I then grabbed the key and get value, and I used that to continue to solving the problem. Feels kind of bad when these interviews are done. It's weird, I haven't had, like, my last big one was with Microsoft, and that was, I think, what, 2 weeks ago now? It like, feels weird to think that, like, skill set is kind of hibernating for 2 years. Yeah, it's, granted, to be completely honest, I don't think 90% of what I did here I'm going to ever touch on the job. But what seems like it's a nightmare is going through and re-interviewing for a better job. Because, I mean, at that point, you've been on the job working for, let's say, like 3-4 years. And you just have to go through and start relocating again. Oh, hello, Chris. It has been a while. You joined us right as I'm about to close off. But yeah, I will do my best to keep streaming, if not daily, at least semi-daily, to until I hear back from Google. I know they've unpaused their PA matching because I've seen one other person from our university use this except when interviewing candidates. Yeah, not looking forward to the sys-design questions in later career. So are you doing what, like SDE or more of like, I guess system design is more like the higher up you get, you maybe are such a thing as a point of diminishing returns for practicing DSA, you think? See, I feel like it feels like I'm never going to stop now. Personally, I think it's not so much a point of diminishing, it's a point of diminishing returns depending on how you look at it, right? Because the first, let's say, like first 150 problems you solve, yeah, are going to be learning the data structures. For the most part, after like 2 months, the only reason I was still doing them, like I was comfortable with pretty much all the data structures, except freaking DP. But the only reason I was doing them, and the only reason you do them, is A, to keep the skills sharp, because you can be comfortable with them, not touch them for 2 weeks, and then come back and have, you know, very difficult time jumping back in the mindset. And the other thing that I really found helpful, it's not so much you're practicing the data structures and algorithms, it's practicing, I guess, problem recognition. Because, for example, you open up a problem, like let's randomly scroll through, let's do this one. You open up the problem, you read the prompt. Google Kickstarts are good if this is too easy. Codeforce is a different flavor, much more math. I don't like math questions then. But yeah, you open it, you read through it, and the perk of having constantly practiced it is you look at it and you're not trying to figure out, okay, which data structure do I use? Because having the experience with the data structure isn't going to help you if you don't know when to apply it. So I honestly, I don't want to read this problem, but I think that's probably the most useful skill that I got, where I can very quickly and easily discern at least what the problem, like what a basic approach to the problem looks like, and work from there. So I think that is probably the most useful thing from continued practice, even after you're comfortable with all the data structures and algorithms. I've never even, what is Codeforces? I've never seen this. Okay, does my... Let's kind of turn the dark theme back on. Yeah, that's so much nicer. It's where the Chads go to compete. Goodness. Is this something you put on your resume? I love the first thing. I hope you have no plans for Valentine's Day. Yeah, I feel like, honestly, binary search is more than enough. Code Forces is something you do if you just, like, enjoy the competition. Binary search and LeetCode is where you go if you're just prepping for interviews, want the job, and you want to be done with it. I don't think there's really a point. Kind of started liking DP in my last interview round. Really? Don't get me wrong, dynamic programming is incredibly useful, it's incredibly helpful to... it's incredibly useful for speeding things up. I think Blend 75 is enough, probably. Except for like quant firms. Quant firms, that's the reason I was excited to land Microsoft and hopefully Google. Great to hear because that's what I did. Yeah, it's the work-life balance for me, honestly, because I will take a pay cut if it means work-life balance. You know, my goal in life is to not live at work. My goal in life is to make enough to get to do things I want to do, hopefully working like 40 hours a week with like maybe a little bit of overtime. Hey, it's good to see you, man. And everyone's solving with understanding is greater than memorizing solutions. Absolutely. And if anything, I would even say, like, don't memorize solutions to specific questions. Take it up a level with, like, abstracts. Instead of memorizing, like, O1 knapsack and O1, like, fractional knapsack, memorize the pattern for, like, that style of problems. And then, from there, it's a lot easier to solve all of those, rather than going from here, having to figure out that general one during the interview, and then going back to the other version. Microsoft? No, I'm still on with Microsoft. I mean, they're just going back in person. That was the whole kind of thing behind it. And there was almost no coding, only silly coding. But yeah, honestly, understanding is always going to be better than memorizing. Granted, I did memorize reversing the linked list in place, and I think it was O1 knapsack. Those are the only two that I've memorized, but have still pretty much no idea how, like, especially O1 knapsack. February 14th was pretty good. I just went out for the evening, and then came back and fell asleep way too late, and then almost overslept another interview prep session. Don't underestimate memorizing, though. Yeah, for sure. I mean, you can, especially for templates. Yeah, memorizing can get you far, but as long as you at least understand what you're memorizing. Alright, it is 11:40. I've got to go eat breakfast. Goodness, why is it always when I'm closing off that we have so many people here? But yeah, thanks everyone for stopping by. I'll be back hopefully 10 a.m. PST tomorrow. So yeah, best of luck to everyone on those interviews. Yeah, Google seems to be a lot better for work-life balance. I think that's one of their biggest perks. They also have a ball pit, which is pretty nice, so. But yeah, take care everyone. Thanks for stopping by. See you tomorrow.